In Chapter 13, Section 5, there's an example on page 523 of the textbook that sets up a problem where there are two different charges. Q1 is 6 nanocoulomb and Q2 is minus 5 nanocoulomb. And they place them at particular positions and then ask about what the force on a third charge that's minus 3 nanocoulomb would be. And so that problem, when set up, looks like figure 13.27, where you have, excuse me, Q1 of 6 nanocoulomb is sort of below and to the left of Q2, which is minus 5 nanocoulomb. And they demonstrate what the electric fields look like. The electric field from the positive charge points away from the positive charge at this position A, so it's pointed up and to the left. And then the electric field from the negative 5 nanocoulomb points back towards the 5 nanocoulomb charge. At this position, the electric field from this slightly smaller charge is pretty close to the same electric field from this positive charge because it's a little bit closer to the smaller charge. And the superposition of those two electric fields points towards this up and to the right direction for the net electric field. The textbook goes through and solves the mathematics for what the force on a third charge, the minus 3 nanocoulomb placed here at position A, and since the net electric field points up and to the right, this being a negative charge, the force points down and to the left, because the force on a negative charge is in the opposite direction of the electric field. So I thought I would set this problem up just to look at it qualitatively, and I'm going to use a PhET simulation that's called electric field hockey, and there's a link to this earlier in the Moodle course I believe in the introduction of chapter 13. So let me just take a look. Yeah, it's here in the electric field introduction section. So I'm going to set this up. When you open this simulation, there will be what they call a puck, because this is field hockey, and it has a positive charge. I'm going to make this the negative Q3, so I'm going to make the puck negative because that's the one charge that's free to move once I start the simulation. I'm going to place these negative charges, and I'm going to put 5 of them here, just to kind of approximate what's in the problem. I think that was 5. And then I'm going to place 6 positive charges down here. And what these arrows are indicating are the forces from on this negative charge. This set of negative charges will have a force on these negative charges to repel them to the left. And these positive charges are going to pull those negative charges down and to the right. And just like the electric fields, these forces are going to superpose on one another. And so there will be a net force that's down and to the left, just to remind ourselves that is the result that we see in the example here. Now, once this puck begins to move, it's going to have an initial force that pulls it down into this direction, but then it's going to move closer to the positive charge and further from the negative charge, and so the force from this positive charge is going to dominate, but it's going to have a velocity that's down and to the left. And so what do you think might happen as it moves down and to the left and gets closer to this charge and further from this charge? So let's see.